In this video, we will be talking about partial fractions and long division, and we will also incorporate our homework. Now, in the first part, we do need to note that a lot of these problems here, we will need to do some kind of factoring, and then we will break this apart into a partial fraction decomposition. And so that the denominator is a product of distinct linear factors. And a good note for us to remember is that in BC, we're only going to have problems where we don't have those repeating linear factors. So hopefully that'll help with some of this. Now, for the first part, we do need to look for a separation here to see what our two fractions might have been for us to have added those. And so looking at this, what we are going to do is first thing is to factor the denominator and see what we end up with. So we're going to have the integral of 1 over x squared minus 4 is going to factor into x minus 2 times x plus 2 dx. And now what we're going to do is we need to find out, well, what in the world did I add together to get this final fraction? And so to decompose our fractions, we know that it was a over x minus 2 plus some b value over x plus 2. And we're going to go through and do some algebra here. We are going to multiply both sides of our equation by x minus 2 times x plus 2. And so if we do that to both sides, then I have 1 left on the left because our denominators would cancel. I'm going to have a times x plus 2 plus b times x minus 2. And then what I'm going to do is distribute the a. So I have ax plus 2a. And then I'm going to have plus bx minus 2b. Now, if we collect our terms, notice here and here, you've got to have some value x, but I don't have that on the left side. So it's safe to say if it's not there that we had 0 x's plus 1. And then here I'm going to put those together. And so that's going to be, if I put those and I'm going to factor out an x, I'm going to have a plus b. And then I'm going to have plus 2a minus 2b. Now these are going to make up our constant value because a and b are just values. And then this first part is going to be our linear just because here you have your x. And a and b, that's going to be what we're trying to find. So we can set up kind of a system of equations here. So that a plus b must correspond with 0. So I'm going to say 0 equals a plus b. And likewise, this positive 1 must correspond with this constant value out here. So 1 equals 2a minus 2b. Now putting this together, it looks like if I had a value maybe for a, I could plug it in. And if we do, what we can do is subtract our b over. So I have negative b equals a. So when I plug this in, I'm going to have 1 equals a. I'm going to put negative b. So that's going to be negative 2b minus 2b. And so I have 1 equals negative 4b. And we have a negative 1/4 for b. And if we plug in back over here for a, we're going to get a is a positive 1/4. So now we're ready to go through and substitute these values back up here and separate our limit. So again, using our values, so we have our integral of, and notice a was a positive 1/4, so I'm going to have 1/4 over x minus 2 dx, and then plus the integral of negative 1/4 over x plus 2 dx. And when I integrate those, we can move that 1/4 out and integrate 1 over x minus 2 dx. And then if I move this out, I have minus 1/4 times the integral of 1 over x plus 2 dx. And so when we go ahead and put those together and integrate, these are going to be natural log. So we're going to have 1/4 natural log absolute value of x minus 2, and then minus 1/4 natural log absolute value of x plus 2, and then plus c. Okay, for our next problem, instead of going through all of the algebra, this way we're going to go through and use our shortcut. And of course, you still kind of start out the same way. You definitely need to start out with factoring the denominator. So we're going to have the integral of x minus 11 over, and if we factor this, we have x minus 5 times x minus 2 dx. And now whenever we go through here, we do need to try to figure out what it was that we put together to get these fractions. And so I'm going to say there was a numerator here for x minus 5 plus, and then a numerator here for x minus 2. Now we're going to go through and we're going to try to solve for a and b. And the way we're going to do that is our cover-up method. And that means we're looking for a value that would make this denominator under a 0. And so that's going to be when x is 5. And so I'm going to substitute it back in over here. And so I'm going to have 5 minus 11 over. Now I'm not going to plug into the same thing here. That's why that's called a cover-up. We're not going to use that portion. We are going to use the x minus 2 though, and so we're going to have 5 minus 2. And so in the numerator we're going to have negative 6 and the denominator 3. So notice a is going to be negative 2. And for b, same idea. So let's go back and we're going to see what makes that denominator 0, which is going to be 2. And so when I go plug in, I'm going to have 2 minus 11 over, and if I plug in here, I don't want to do that. I'm going to get a 0. So I'm going to plug in with the 5. And so here I'm going to have b equals negative 9 over negative 3. So that's going to give me a positive 3. So that's quite a bit shorter. And now let's go do our integral. We have everything we need to go ahead and finish the problem. So we're going to rewrite this as the integral of negative 2 over x minus 5 dx, and then plus the integral of 3 over x minus 2 dx. And while we're doing that, of course, we can move out our 2's and the 3, and we're going to end up with a natural log, absolute value of x minus 5, plus 3 natural log, absolute value of x minus 2, and then don't forget the plus c. Okay, same process for our next problem. So over here to the side, we have 3x plus 6. And I'm going to factor the denominator to be x times x plus 3. And so I know, again, this was a over some value x, and b over x plus 3. And again, using our cover-up method to solve for a, this denominator would be 0 when x is 0. So I'm going to have 3 times 0 plus 6 over 0 plus 3. And so I'm going to have 6 over 3, which is 2. So we found that one pretty quickly. And then for b, same process. Here the denominator would be 0 when x is negative 3. So I'm going to have 3 times negative 3 plus 6 over negative 3. And so I'm going to have negative 9 plus 6 over negative 3. Now it looks like that's going to be a positive 1. And so now, again, we're ready to do our integration. So I'm going to integrate 2 over x dx plus the integral of 1 over x plus 3 dx. And then that's going to give me 2 natural log absolute value of x plus natural log absolute value of x plus 3, and then plus c. All right, moving on to question 4. This time we have 3 different terms in the denominator, but that's going to be okay. It's not going to change our process. It's just going to add one more step to it. And in the denominator we have x, and then this will factor to x minus 2 times x plus 2. And now we have a over x plus some value b over x minus 2 plus c over x plus 2. And to find our values again, same process. So a is going to be equal to, well, here that's going to be a 0. So in the numerator, I'm going to have 12 over, and if I plug in 0, I have negative 2 times positive 2. So that's 12 over negative 4, and that's going to give me negative 3. Now to find b, again, same process. So here x is going to be 2, and so plugging in, we're going to have 2 squared plus 24 plus 12, and that's all over 2 times 4. And so whenever we go through that one, it looks like in the numerator we're going to have 28, and 12 is going to be 40 over 8, and that's going to give us 5. And finally, part C, that one we're going to need a negative 2. So substituting in, we're going to have 4 minus 24 plus 12 over, and again we're plugging in negative 2, and so that's going to be negative 2 times negative 4, and so we're going to get negative 8 over positive 8, and that's going to give us a negative 1. So now that we have all of our numerators, we can go through and integrate. And so again, we are going to integrate. A was negative 3, so we're going to have negative 3 over x dx plus the integral, and we're going to do 5 over x minus 2 dx, and then plus the integral of, what was b? C was negative 1 over x plus 2. And so now we're going to have negative 3 times the natural log, absolute value of x, plus 5 times the natural log, absolute value of x minus 2, and then minus natural log, absolute value of x plus 2. And then, of course, our plus c. Okay, this next portion that we're going to do is going to be with our long division. And what we will really do for this is we're going to incorporate our synthetic division. Now, whenever we know that we're going to have to do our long division is whenever we have an improper fraction, or in this case, improper rational expression. In other words, notice that the leading power in the numerator is larger than the leading power in the denominator. So we have an improper fraction. And so what we will need to do is go through our division, and then we should end up with something that we can integrate pretty easily. So what we're going to do in our synthetic division, and it's been a while since we've done this, to start with, again, we're looking for a 0 in the denominator. So that's going to give us a negative 4. And then what we're going to do is pull all of these coefficients, and we need to make sure they're in exponent descending form. And if any one of them's missing, then we need to incorporate a 0. So for this one, we have 3, 8, negative 10, and 15. And with our synthetic division, we're always going to drop down our 3. And then from here to here, you always multiply. And so if we multiply, that's going to give us negative 12. That negative 12 is going to go here. And then you always combine these. And so that's going to give me a negative 4. We repeat this process, so we're going to get a positive 16. Combine, and we get a positive 6. Multiply here, and you get a negative 24. And then combine those, and you're going to get negative 9. So let's see, what in the world have we created here? Well, we have found something that now we can integrate. And what it's going to look like is we started with the cube, but we factored out really an x here. We dropped it down a power. So it's going to be 3x squared. Then we're going to have minus 4x plus 6. And then we're going to have plus a remainder of negative 9 over x plus 4 dx. Now this turns into something that we can fairly quickly integrate. And so when we go through our integration, we're going to have 3x to the third over 3 minus 4x squared over 2 plus 6x. And then right here, this is natural log again. You can move the negative 9 out, and then you're going to have natural log absolute value of x plus 4, and then plus c. You're welcome to go back and reduce some of this if you want to. I will leave that for you to do if you want. All right, again, number 6. As strange as this looks, here it's going to be really a couple of different things you could do with this. If we go through our synthetic division, it's not going to work out for us so much because there's looking at this denominator, it's going to be a mess. If we try to do our long division, well, that's also going to work out kind of strangely. So let's just do our long division. It's going to look strange. You've got 2x minus 2. Now I'm going to divide that into x minus 5. And so what can I multiply to 2x to make that just an x? Well, I multiply it by a half. And so that's going to be x here. If I multiply that down, that's going to be x. And if I multiply that here, it's going to be a 1. But just like any other long division, you've got to come back and subtract. X minus x is 0 x's. Negative 5 minus the negative 1 is going to be a negative 4. And so now look at what we've created, which is something weird. We're going to have the integral of 1/2, because it will go 1/2. And then we have plus negative 4 over 2x minus 2 dx. And as you can tell, I'm not a fan of this problem. If I integrate 1/2, I get 1/2 x. And here, we can reduce this down. That's going to be 1 and 1. So we're going to have minus 2 natural log absolute value of x minus 1, and then plus c. Really strange problem there. Okay, for our next problem, if we set that denominator equal to 0, then we see that x is going to be 1, and that tells us what we're going to divide through with our synthetic division. Now, looking at our exponents, we know we're missing some numbers up here, and that's okay. We can fill those in with a 0. So we're missing x squared, so I'm going to put a 0 for x squared. We have a 1 for the coefficient of x, and then I'm going to put a 0 in for the missing number. So translating this, that would have been 0x cubed plus 0x squared plus x plus 0. So notice I didn't change the value, I just had some placeholders for our division. And again, with our synthetic division, we do drop that 1 down. And so if we multiply here, we get 1, combine that. And notice we can go through that pretty quickly there. And so look at what we have now to integrate. We had a cube, but we're going to drop this down a power. So that's going to be 1x squared plus x plus 2 plus 2 over what we were dividing by, which is x minus 1. Now we're ready to integrate this. So that's going to be x cubed over 3 plus x squared over 2 plus 2x plus 2 times the natural log of the absolute value of x minus 1 plus c. Okay, so now our next problem we will have to do by long division because the denominator is not nice, neat, linear terms. And so here we're going to go through. We're going to have 2x cubed plus x squared minus 11x plus 20. And again, you're going to try to see what can I multiply to x squared to get 2x cubed. And we are incorporating 3 terms, so go all the way over to the third. And you're going to multiply by 2x. So I'm going to have 2x cubed plus 4x squared minus 6x. And now we do subtract. And when we subtract, those terms should always cancel. And then whenever we combine our next terms, we have negative 3x squared. And then it looks like we're going to get a negative 5x. And then we will bring down plus 20. And again, comparing here, it looks like we need to multiply by negative 3. And when I multiply this through, I get negative 3x squared minus 6x, and then minus 9. And then we subtract, and again, those will cancel. And it looks like I have an x, and then here 20 minus a negative 9, 29. And just to make sure I've not, oh, yeah, there it is. I was thinking that should cancel out, make that a little bit smaller. It's going to be plus 11. Goodness. All right, now let's see what we have. We have this to integrate. And so when we do that, we have the integral of 2x minus 3 plus x plus 11, that was our remainder, over x squared plus 2x minus 3. Now, the first two things here is going to be pretty easy to integrate. We're going to have here, if I integrate 2x, that's going to become x squared minus 3x. But look at this. We still have the integral of x plus 11 over, oh dear, that it looks like we're going to have to factor this. So that's going to be a positive 3 and a negative 1. And we are also going to have to do our partial fractions here. So over to this side, this is the problem that just keeps giving. We have x plus 11 over x plus 3 times x minus 1. And we're going to say that's equal to some value over x plus 3 plus some value over x minus 1. Now let's go ahead and solve for a. We need to plug in a negative 3 plus 11 over negative 3 minus 1. And so that's going to give me 8 over negative 4. So that's going to be a negative 2 for a. And then let's see, our next problem, we are going to have b. And the denominator for that's going to be a 1. So I'm going to have 1 plus 11 over 1 plus 3. And so 12 over 4 is 3. All right, now we're ready to put all of this back together. Okay, so this portion here, when I integrate that, so I'm going to go ahead and just write the entire answer because we can bring down that top part plus. And then a was negative 2, so that's going to be, I don't guess I need that plus, I need negative 2 and then natural log absolute value of x plus 3, and then plus 3 natural log absolute value of x minus 1, and then plus c. Okay, for these, we will do these in class if time permits. These are kind of going a little extra than the AP exams, so we will see if we have time, we will do these. Now let's go ahead and look at your homework problems. So for the first one, again, we are going through and looking at our partial fractions for these. And so with this, again, we are separating out, and they've already separated for us some. So I know this is 8 over x minus 2 times x plus 6. And I want to know what value a over x minus 2 plus what value b over x plus 6. So again, to solve for a, we need to plug in a 2, so that's going to give me 8 over 8, which is 1. And for b, we need to plug in a negative 6, so it's going to be negative 6 minus 2, so that's going to give me a negative 1. So now we're ready to integrate these. We have the integral of 1 over x minus 2 dx plus the integral of negative 1 over x plus 6 dx. And so when we integrate these, we have the natural log, the absolute value of x minus 2, minus natural log, absolute value of x plus 6, and then that's going to be plus c. Okay, moving on to number 2, very similar. Again, we need to break this apart and see what's going on here. And so 1 over x minus 2 times x minus 4. And that's going to be a over x minus 2 plus a b value over x minus 4. So let's see. A, we're going to plug in a 2. And so 2 minus 4 here. So we're going to get a negative 1/2. For b, we're plugging in a 4. So we're going to have 1 over 4 minus 2. So that's going to give me a positive 1/2. And so here we're putting all of this back together. I have negative 1/2 over x minus 2 dx plus the integral of 1/2 over x minus 4 dx. Now, let's go ahead and integrate this. So I have negative 1/2 times the natural log, the absolute value of x minus 2, plus 1/2 natural log x minus 4, and then we have plus c. Okay, so for, again, this problem, we do divide this up. And so we are going to have x plus 34 over x minus 6 times x plus 2. And then that, again, we're going to decompose this, a over x minus 6 plus b over x plus 2. And again, dividing it here. To solve for a, we're substituting in a 6 plus 34 over 6 plus 2. And so that looks like that's going to be a 5. For b, we're plugging in a negative 2 plus 34 over negative 2 minus 6. And so that looks like that's going to be 32 over negative 8, so negative 4. And so now we can go back and look at our integral. We're going to have 5 over x minus 6 dx plus the integral of negative 4 over x plus 2 dx. And now when we integrate, we have 5 times the natural log, the absolute value of x minus 6, minus 4 natural log, absolute value of x plus 2, and then plus c. All right, so let's move on to our next problem. Again, very similar. We need to break this apart and see what we have. The denominator, we need to factor it. And so that looks like it's going to be an x plus 2 times an x minus 1. And so I know there's an a value over x plus 2, and there was a b value over x minus 1. To solve for a, we're going to sub in negative 2, and then negative 2 minus 1. So that's going to be 6 over negative 3, which is going to be a negative 2. For b, again, same work here. We're going to say b is going to be equal to, and we're plugging in a positive 1 this time. So it looks like we're going to end up with 9 over 3, so we get 3. And now we are integrating again. We have negative 2 over x plus 2 dx plus the integral of 3 over x minus 1 dx. And then we will have negative 2 natural log absolute value of x plus 2 plus 3 natural log absolute value of x minus 1, and then plus c. Okay, so let's go ahead and divide this up again. We will have 2x minus 1 in the numerator, and then we need to factor the denominator. And so we're going to end up with 2x minus 1 over x minus 2 times x minus 3. And again, we need to find our value of a over x minus 2 plus our value of b over x minus 3. And again, going through with that one, substituting in, we are going to find a. We're going to plug in a 2, so that's going to be 4 minus 1 over 2 minus 3. So that's going to give us a negative 3. To find b, we are going to plug in a 3, so that's going to give me 6 minus 1 over 1, so that's going to give me a 5. And so here we're going to integrate negative 3 over x minus 2 dx plus integral of 5 over x minus 3 dx. And so we have negative 3 natural log absolute value of x minus 2 plus 5 natural log absolute value x minus 3, and then plus c. All right, the next one. Wow, this one's already factored for us, so that's awfully sweet of them. But again, still plugging in though, this one's kind of unique because all you have is a 1 in the numerator. So really, there's not going to be a whole lot of working out, and these weird problems are usually the ones that trip us up. So I'm going to keep the same pattern here that we've been doing, so hopefully it doesn't mess us up. And we have our c over x minus 2. And so to find a, we need to plug in a 3. So really that's going to be 1 over 3 plus 2 times 3 minus 2. So that's going to give us a 1/5. To find b, we're going to plug in a negative 2. So that's going to be negative 2 minus 3, so negative 5. And then negative 2 minus 2, that's a negative 4. So that's going to give us 1 over 20. And then c, we have 1 over. And we're going to plug in a 2. So we're going to have negative 1 times 4, so negative 1/4. So that one almost looked like it would be a little bit tougher. And so again, going back, and let's go ahead and just write our final answer for this one. So a, we had 1/5, and that's going to be the natural log absolute value of x minus 3, plus b is 1 over 20 natural log absolute value of x plus 2, and then c was negative 1/4 natural log absolute value of x minus 2, and then don't forget your plus c. Okay, so let's go ahead and rewrite this with a factored denominator. And in that denominator, we're going to have x and then x minus 2 times x plus 2. And again, we are separating this out, a over x plus b over x minus 2 plus c over x plus 2. And to find out our values for a, we need to plug in a 0, so that's going to give us negative 8 over negative 2 times positive 2. So that's going to give us a positive 2 there. And then for b, we're plugging in a positive 2, so that's going to give us 20 minus 8 over 2 times 4. And so that should generate negative 8 over positive 8, so negative 1. And then C, we are plugging in negative 2. So that's going to be negative 2, so 420. And then plus 20 minus 8. And then all of that is going to be over. Going to have negative 2 times negative 4. And so let's see, that's going to give us 32 over 8. So that's going to give us a positive 4. And so now we're ready to go through. And again, we can go ahead and write our answers because we are integrating there. So we're going to have 2 natural log absolute value of x minus natural log absolute value of x minus 2 plus, and then we have our 4 natural log absolute value of x plus 2, and then we have plus c. Okay, number 8, again, more of the same fun. And again, breaking this apart, we do need to factor the denominator. And so we're going to have 11x plus 2 over, we've got 2x and x. It looks like we have 3 and 1 minus 3 positive 1. So we're going to have a over 2x plus 1 plus b over x minus 3. So to find a, now this time we're going to have to solve, and we're going to get a negative 1/2 there. So, oh joy, joy, we're going to have some fractions. So we're going to have 11 times negative 1/2 plus 2 over negative 1/2 minus 3. Yay. So we're going to have a negative 11/2 plus 4 over 2. All of that's over negative 1/2 minus 6 over 2. I just built some nasty fractions here. So that's going to give me negative 7/2 over positive 7/2. Nope, negative 7/2 again. I was trying to multiply that. So that's going to generate a positive 1. How kind of them. Now for B, we're subbing in a 3, so that's going to give me 33 plus 2 over 6 plus 1, 7. So that looks like that's going to be 5. And now we're ready just to write our answer. If we're integrating all of that, so A was 1. So that's going to be the natural log absolute value of 2x plus 1 plus 5 times the natural log absolute value x minus 3, and then plus c. Okay, number 9 is going to incorporate factor by grouping in the denominator, which is something we've not seen in a while. So what we would need to do is group those together and take out a GCF. And if we do that, then for the first one, we can factor out, it looks like an x squared. And so you would have an x plus 5 left. Over here, it looks like you can factor out a negative 4. And so you're going to have an x plus 5 left. And this is how you knew you had it right. So we're going to put x plus 5. And then we have x squared minus 4. But x squared minus 4 will factor again. And so that's going to be x plus 2 times x minus 2. So, good gracious, what a problem. All right, so now we can go through and set up our problem. And again, you're going to have A, B, and C. And so, however you set it up, if you can go from here and say, well, I know A over x plus 5, and then we're going to have a b over x plus 2 plus a c over x minus 2. We can do that. And then to solve for a, well, for a, we would plug in a negative 5. So that's going to be 4 times 25, so 100. And then minus 55. And then plus 18. And all of that is over for plugging in again your negative 5. So our other two, negative 5 plus 2, that's going to be negative 3. And that's going to be negative 7. So let's see what we end up with here. 45 plus 18, we're going to have 13, 63 over 3 times 7 is 21. So that looks like a 3. So I know A is going to be 3. And now for B, it looks like for B we're plugging in a negative 2. So that's going to give us 16 minus 22 plus 18 over, and then plugging into the denominator, again we're plugging in a negative 2. So we're going to have 3 times negative 4. And so what we're going to get there, it looks like, working that out, we're going to have 4, 14, 12 over 12. So that's going to give us a negative 1. Okay, so now for C, same process here for C, and it looks like with C you should get a positive 2, working that one out. And now what we're going to do is go through our integration. So we're going to have here 3 times the natural log, absolute value of x plus 5. And then B, we're going to have minus 1, natural log, absolute value of x plus 2. And then C is going to be plus 2 natural log, absolute value of x minus 2, and then plus C. All right, and then number 10. Number 10, same process again. And I'm just going to give you the final answer for this one. And so if we can't get it from there, then let me know. The final answer for 10, you should have a 1/2 times 3 natural log absolute value of x plus 2 minus 4 times the natural log absolute value of x plus 3, and then plus natural log absolute value of x minus 4, and then we have our plus C. And again, let me know if you can't get it, and we will work it out in class tomorrow. Okay, now for our long division part. So again, here there's no great nice way in order to do this. So we are going to do our long division. And so x plus 4 is going to divide into x plus 3. And notice that x, what can I multiply that to get an x? And that's going to be a 1. So I'm going to have x plus 4. And again, I need to subtract that. And so that's going to generate a negative 1. So I can rewrite all of that to be 1 plus negative 1 over x plus 4 dx. And so when I integrate that, I'm going to have x minus the natural log absolute value of x plus 4, and then plus c. Okay, with this one, we can either do synthetic division or we can do long division. I'm a fan of synthetic division when it can be used simply because it seems faster. Here we are missing a 0x. And so if we did list out our terms and do our synthetic division, we have 1, and then we have 0, and we have 3. And then setting that denominator equal to 0, I'm going to divide through by negative 2. And so again, from here to here, you need to multiply. So that's going to give us negative 2, and then you combine, and then multiply again and combine here. So that's going to give us 7. So here we can rewrite this. We started out with x squared, but we've divided out an x, so we're going to drop it a term. It's going to be x minus 2 plus our remainder of 7 over x plus 2 dx. And now we run through and do our integration. We're going to have x squared plus 2 minus 2x plus 7 times the natural log, absolute value of x plus 2, and then plus c. Okay, number 13, again, we can either use synthetic division or long division, and I'm a fan of synthetic division when we can use it. And for this one, we do need to incorporate a 0x again. So we're going to have 4 here, and then let's list out our coefficients. We have 3, and then we have 0 and negative 2. Again, dropping down our 3, so that's going to give us 12, and we're going to combine 48. Oh my goodness, that's going to give us 46. Craziness. So when rewriting this, we're going to have the integral of 3x plus 12 plus 46 over x minus 4. And so that's going to give us 3x squared over 2 plus 12x plus 46 times the natural log, absolute value of x minus 4, and then plus c. Okay, so again for this one, I would do long division again. And so to set up this problem, we are going to go through and we're going to have 5. And then let's see, we have 4, negative 12, and then negative 25. Again, drop our 4 down, so that's going to give us 20 and 8, 40, and combine that, it's going to be 15. And so we're really integrating 4x plus 8 plus 15 over x minus 5. And so we're going to have 4x squared over 2 plus 8x plus 15 times the natural log, absolute value of x minus 5. And then, of course, don't forget your plus c, because small animals will die if you do. So now what we're going to do, again, is our synthetic division. Do note that we are missing our x squared, so we will incorporate 0x squared. And so we're going to have 1, and then we have 5, 0, 3, and negative 2. And again, we're going to drop our 5, multiply. And again, this goes through fairly quickly. And so we're ended up with our remainder of 6. So again, we're able to rewrite this to be the integral of 5x squared plus 5x plus 8 plus our remainder of 6 over our divisor. All right, and now we're ready to integrate. So that's going to be 5x cubed over 3 plus 5x squared over 2 plus 8x plus 6 times the natural log of the absolute value of x minus 1, and then plus c. All right, now we're ready for the problems that never end. Here, again, it would be great if we could factor or do something with this. It's not where we can. Here, we're not, even synthetic division is not going to work because our denominator is not linear here. We can do it with the other, but that is more trouble than it's worth. So let's go ahead, and we have our x squared. We're just going to do long division, and we can even incorporate a plus 0 here to hold that place. And then inside we have x squared minus x plus 1. And so to multiply here to get here, well, that's just a 1. So that's going to give us x squared and then plus x plus 0. Then we will subtract, and yay, those cancel. So we're going to get a negative 2x, and then 1 minus 0 is a 1. Now we're looking at integrating. We have a 1 plus, and then we have negative 2x plus 1 over x squared plus x. Well, now we can take our x squared plus x. Let's take this portion here, And we can now do some partial fractions with that. So we're going to break that apart. And I'm just going to focus on that portion. Then we'll come back and grab the 1. Here, that is going to be negative 2x plus 1 over x times x plus 1. And so we've got to find out a over x. This is going all the way back to here. And so to solve for a, we're going to sub in a 0. And so that's going to give us a 1. And to solve for b, we're plugging in a negative 1. And so negative 1, so that's going to give us a negative 3. And so now we can go ahead and look at what all we have to integrate. So we've rewritten all of that mess. We have a 1 plus, and then we have 1 over x, and then minus 3 over x plus 1, and then dx. Now we're ready to integrate all that. So we have x plus natural log absolute value of x minus 3 natural log absolute value of x plus 1. Okay, last problem that we're going to do. The other two, if we have time, we'll come back to them. But we're going to focus mainly what's on the AP exam. So from here, again, notice those are same powers. So let's go ahead and do our long division. We have x squared minus 4x minus 5. And then we're dividing into 4x squared minus 5x minus 15. All of our terms are present. And so it looks like I need to multiply by 4. So I'm going to have 4x squared minus 16x minus 20. And then we come back and subtract. And those do cancel. And so we're going to have negative 5x plus 16, so 11x. Negative 15 minus the negative 20, so plus 5. And now we're going to go ahead and rewrite this so that I'm really looking at the integral of 4 plus 11x plus 5 over x squared minus 4x minus 5. And once again, this pattern is still going to be the same. We're going to have to pull this portion down and go ahead and do some factoring and partial fractions here. Looks like we're going to have x minus 5 times x plus 1. And so we have a over x minus 5 plus b over x plus 1. And so to solve for a, we're going to plug in a 5, so the top's going to be 60, denominator 6, so a is going to be 10. B, we're plugging in a negative 1, so that's going to be negative 6 over negative 6, so positive 1. And so now we're getting a little bit closer, so we're going to integrate 4 plus. And then a was going to be 10 over x minus 5 plus 1 over x plus 1. Yay! And now for our integration, we're going to have 4x plus 10 natural log absolute value x minus 5 plus natural log absolute value x plus 1 and then plus c. Okay, these last couple of problems, we are going to wait to do those. It's not that we can't do them. I don't know how much time we're going to have. So for 18 and for 19, we are going to skip those for right now.